My name is Michael Fleischman. I'm CTO and co-founder of OpenSpace. And today I will be talking to you about Spatial AI. Spatial AI is the name of the technology that we've developed here at OpenSpace that powers most of our advanced features. And today I'll be talking a little bit about how it works and where it came from, talking about how it intersects two megatrends in the world of artificial intelligence, spatial computing on the one hand, and generative AI on the other. And then I'll be taking you under the hood to show you how Spatial AI powers some of the product features that Neil mentioned earlier today. All right, so I'm sure many of you have noticed the amount of interest in AI recently and how it kind of feels like people are getting more and more interested in AI. And if you're like me, every time you open up your feeds or news, there's some new article about artificial intelligence, whether it's about how impressive the latest technology, the latest models are coming out of the field of AI, or whether it's about how much promise AI has for the future, how much good it can do. But it just seems like everybody's got an opinion about AI these days. And if you feel like it's more now than it ever has been before, well, you're right. In fact, if you look at the use of the term AI over time, you can see that just in the last decade or so, interest in AI has really skyrocketed more than ever before. In fact, before the last decade, interest in AI and kind of use of the term AI in popular media, publications has been pretty steady over time since AI was really coined as a term back in the late 40s and early 50s. Other than a few kind of peaks in interest around AI in the late 60s and late 80s, interest has pretty much been on par. And that kind of peak, generally, those little peaks generally correspond to big pop culture media events that co-occur. So, for example, in 1968, the release of the movie 2001: A Space Odyssey, largely considered one of the best movies about artificial intelligence, was released, and there was a little kind of pop in general interest in AI around that. Then again, in 1986, the single best movie about AI, The Terminator, was released, at least in my opinion. And you see another kind of similar peak in interest around that time. But other than that, interest was pretty steady. And that's not because there weren't really important things coming out of the world of AI that were talked about in the media. Even all the way back in 1960, you can see here a picture of a man named Arthur Samuelson, who invented the first machine that could beat a human at the game of checkers. That was then followed a few decades later in 1996, when a machine by IBM called Deep Blue beat Garry Kasparov, the first time a machine beat a grandmaster at the game of chess. And then a little bit later, again, IBM machine, Watson this time, beat humans at the game of Jeopardy, the first time that ever happened, largely considered even more of an event than chess, because Jeopardy is such a wide-ranging array of questions that can be answered there. And so interest in AI has been skyrocketing in the last decade or so. And I want to posit that the reason for that has to do with two megatrends that have been unfolding in the world of AI, and talk about each one and describe where they come from. The first one is called spatial computing. Now, spatial computing is a term that refers to any type of artificial intelligence that kind of has to do with the environment and working in the real world. It's a term that's actually not very new. It was first coined in the early 1980s, really in the context of GIS, geospatial information systems. And this was spatial computing at kind of a global scale. So it had to do with maps, and it had to do with satellites and just kind of large scale spatial computing. Many of you may know spatial computing, though, for its more recent incarnation, when it has to do with virtual reality. So this is an example here, a picture of Apple's Vision Pro headset. And Apple is interesting. They've actually co-opted the term spatial computing. They actually use it specifically to refer to virtual reality. However, spatial computing has a much wider set of things that are incorporated by that. For example, autonomous vehicles. So self-driving cars are an example of spatial computing, as are robots and drones. These are all examples of spatial computing, and really kind of getting a sense of why this is spiking interest in AI, because really what we're seeing over the last decade is a lot of the concepts that were made popular in science fiction movies are actually coming to real life, or at least getting closer to reality these days. So I want to posit and think about why that might be the case. And I think there are a number of reasons why spatial computing has really come into its own in the last decade or so. One, which is well commented on, which just has to do with machines getting much better. So this is a kind of classic example here. On the left, you see an image of the guts of one of the best machines that was invented in the 1940s. It's called the ENIAC machine. And then for comparison, on the right are the guts of one of the best machines that you see today, which is the inside of an iPhone 5. So right off the bat, you can see a comparison there between a machine that takes up a whole room on the left versus one that fits in your pocket on the right. But more than that, that machine that fits in your pocket is hundreds of thousands of times faster than the room-sized machine from the 40s on your left. And not only that, but tens of thousands of times cheaper than that large-scale machine. And so really see machines getting faster. And that has powered a lot of the advances in computers, and specifically for spatial computing in the last decade. But it's not the only thing, because it's not just the inside of these machines, but the sensor technology has also improved radically in the last 10 years. So cameras are getting cheaper and smaller and better all the time. And they're just showing up everywhere. The self-driving car that I showed you in a couple of slides ago, that has over 30 cameras in it, just in that car alone. The Vision Pro, Apple's headset for virtual reality, 12 cameras just in those pair of goggles right there. In fact, this idea of camera ubiquity, the idea that cameras will be everywhere, was one of the trends that Jeevan, Philip, and I had identified early on, and one of the reasons why we decided to start OpenSpace in the first place. What we thought was that if we could ride this wave of new sensor technology, they're getting smaller and cheaper all the time, we can then combine that with some of the algorithmic advances that were happening in spatial computing for self-driving cars and virtual reality, and apply that to the world of reality capture specifically for construction. So we started to use technologies like structure from motion and SLAM technology, simultaneous localization and mapping, applying that to videos that you could take with just a small 360 camera on your hard hat, pinning each frame of video to the exact location where the user was when they took it, and then creating these 3D models, these Google Street Views from that video. And our bet was if cameras got cheaper and easier to come by and these algorithms continue to improve, we could make a system that was so easy to use, so fast that customers would just love to capture that data. And the usage statistics that you saw earlier are proving that out. So far today, customers in the last 5 years have captured more than 30 billion square feet of data based on the technologies we've developed around spatial computing, specifically for construction. So that is one megatrend that is part of the spatial AI platform that we've been developing. The next one, which is one that's been in the news even more than spatial AI, is what's called generative AI. Generative AI or large language models, these are all terms for a suite of AI algorithms that all basically combine to do anything that's generating content is considered generative AI. So whether it's generating text or speech, or whether you're generating images or video, these are all systems that are generating content. They're called generative AI. And really where we've seen them pop up, particularly in the media, is because they're being used to power a new class of AI assistants, also called chatbots or co-pilots. So ChatGPT is probably the most famous of these chatbots that was released over a year ago, just under 2 years ago, actually, I believe, and represents a huge leap forward in the power of AI assistants and chatbots, well more powerful than anything before because of generative AI. But those aren't the first technologies. The less powered chatbots that you're probably more familiar with even are the ones that are actually on your phone in your pocket right now. So Siri, for example, Alexa, Google Assistant, these are all examples of less powerful chatbots that really have paved the way for what we're seeing with this generative AI revolution with the ChatGPTs. But even Siri is not the first chatbot. Many of you may remember one of the earliest chatbots that came out. I don't even know if you would call this artificial intelligence. This is an example called Clippy. This was introduced as part of Microsoft's Office platform in the late 90s and was kind of universally panned, really not very good at its job, and then was retired shortly thereafter. But even Clippy is just one in a kind of long chain in the history of AI assistants and these chatbot and co-pilots. the kind of idea behind AI assistance goes all the way back to the founding of artificial intelligence. And one of the first people to talk about this was a man named J.C.R. Licklider. He wrote a paper in 1960 called Man-Computer Symbiosis. And what this paper talked about, really a revolutionary paper, because what he wanted to say was there's a different idea of what computers can do, a different interaction model that he wanted to pose. See, before him, everybody kind of thought of computers as being a replacement for human labor. In fact, the word computer used to be a job title for humans. You could get a job as a computer. And what you would do is you would sit there and you would do computations, essentially math problems. That was a career. And these machines that were invented were called computers because they replaced the human computers that existed before them. Now, what Licklider thought was that this was not actually the best use of computers. And really the better way to think about computers is that they could interact with humans, essentially work together with humans to allow humans to do their same job, but to do it 10 times better or faster or more efficiently. He thought of computers as giving humans superpowers to help them do their tasks easier. And so in the spirit of Licklider, I actually tried to use ChatGPT as I was preparing this talk. I asked ChatGPT to create a summary of man-computer symbiosis, just a short one for me. And I'll show it to you now because I thought it was pretty cool. ChatGPT says, man-computer symbiosis is humans and computers intertwined in a powerful dance of thought, expanding their combined intelligence beyond reach. So I thought it's pretty good, pretty impressive, kind of poetic even. Not exactly what I had in mind when I was looking for a summary, but still pretty impressive. And just for fun, I also asked the system to generate an image, an illustration to go along with man-computer symbiosis. And this is what it gave me for that. So kind of spooky, but still pretty impressive. There's a lot going on with these machines. But what is generative AI? It's powering this revolution in AI assistance. But what is actually going on with that? How does it work? And so I'm going to attempt to answer this question, and I'm going to attempt to do it in the best way I know how, which is using memes. So I'm actually going to try and answer 3 questions about generative AI with memes. The first one being, why now? Why is this happening now? Why are we seeing these revolutions just in the last few years? And the answer to that has a lot to do with transformers. So I should say generative AI is a learning algorithm. It's a type of AI called machine learning. And the way it works is that it takes a whole bunch of data, usually from the internet, puts it up and starts crunching through that data. And it actually starts to learn from the data how to do specific tasks. Now, before transformers, the way this worked was that you had to load all of this data into the memory of a single machine. And so you were kind of capped at how much a system could learn, how much data it could learn from based on how much memory you had for a specific machine. Now, what transformers did, one of the main things, the main innovations it provided, is that it allowed us to start training these systems in parallel across multiple machines at the same time. So you could break up that data, put it on lots of different machines, and then do your training in parallel. And what this did was it moved the kind of limitations of these systems away from the physical memory that a single machine had. Now the only limitation you have is just how much money you're willing to spend to rent machines to do this training across lots of different servers at the same time. And this is kind of why you see a lot of these language models coming out of these giant companies like Google and Meta and even OpenAI, because they have a lot of money to spend to rent these machines to crunch these numbers. But what is the system actually learning? What is actually going on as it's crunching these numbers across tens of thousands of machines or even more? And the answer to this is, I think, actually the most interesting, because it's actually learning something very simple. All these systems are learning is how to predict the next word in a sentence. And so what the system does is, as it takes up all of this data, trillions of sentences that it gets from the internet and various other places. And it works similarly with images and video for pixels, but I'll use sentences and words as the example here. What the system is given is all of these sentences, and then it's shown the first part of the sentence, and then the last part is hidden. And then what the system tries to do is predict what that hidden word is. And as it goes through these trillions of sentences, Every time it tries, it gets a little bit better until by the end, it's actually incredibly good at doing this very simple task of predicting the next word in a sentence. And what's really remarkable about this is that these systems learn to not only they learn to encode tons of knowledge, right? But not just factual knowledge, not knowledge like who was the first president of the United States or who killed Abraham Lincoln or stuff like that. It learns that too. But what it is also learning is all of this common sense knowledge about the world around us. So, for example, if I were to take this bottle of water and I were to drop it on the floor, it would be able to predict that water might spill all over the floor and that somebody walking by might slip on that water and hurt themselves. And somebody might have to come clean up that water. All these other kind of correlated, related facts that come about that you and I just learn by living in the world. The system is actually able to actually learn all of this information. And this is actually really critical. This is stuff that people have been trying to push into machines since the very beginning of AI. And no one has ever really been able to encode that information effectively until now with these very simple models. And so these simple models are called foundation models because they are actually the foundation of how these larger systems like ChatGPT work. But they're not enough just to make ChatGPT work. In fact, it brings us to the next question of how do these AI assistants actually take advantage of these foundation models? And the answer to this has to do with something called fine-tuning. Fine-tuning is the next step in the process because the foundation model alone is not going to do things like answer questions for you. It doesn't do that. All it does is predict the next word in a sentence. So in fine-tuning, there's another stage where now humans get involved and they're actually training the system very carefully and intentionally. They're listening to what the system says, asking it questions, looking at its responses, and then telling the system whether it did a good job or a bad job. And it does this thousands, tens of thousands of times. It takes a lot of effort and labor to do this, but essentially it's teaching the system how to do specific tasks. So going from a foundation model, a basic baseline system trained on trillions of data points to one that can actually do much more specific tasks like question answering or summarizing text or things like that. And these systems learn to do that exceptionally well. And so just to give you a sense of how well these things do, I want to show an example, just a video we put together here to kind of highlight how well these off-the-shelf generative AI systems work. And so the video I'm going to show you is a time-lapse video from one of our customers' construction sites, actually the World War II museum in New Orleans. And what we did is we asked ChatGPT to go through and watch this time-lapse video of a construction site and create a narration of that video. And in particular, to create a narration of the video as though it was a nature documentary, and specifically as though it was being narrated by a very famous nature documentarian named David Attenborough. And then even more than that, we gave it to a system to take that narration and actually generate it in the actual voice of the real David Attenborough. So it really sounds like him. So I want to just show this to you because I think it is pretty cool.
In the midst of a city's constant hum, a remarkable transformation unfolds. Within these steel skeletons, a testament to human ingenuity and determination takes shape. Just as a colony of bees crafts its hive, workers, artisans of construction, collaborate in a meticulous dance of creation.
A meticulous dance of creation. I particularly like that last line. Again, very poetic. These systems are poetic for some reason, but just in general, incredibly impressive. And I will tell you, 5 years ago, I would have been shocked if I had known that something like this would have been possible with AI systems at all. But for as impressive as it is, there is something that is kind of missing, or something that we've noticed, that many people have noticed here. And that is that while it's very impressive what these systems do, it's not exactly useful. And so this is something that has actually shown up, and a number of people have noticed this in many different industries. And DPR wrote a report about this earlier this year, where they really, I think they put it nicely, in that they tested out these off-the-shelf ChatGPT systems in construction-related tasks. And what they found is that those systems are not necessarily wrong, although they can be. Hallucinations are definitely a problem, and that is something that you have to work around. But even when they're not hallucinating and they're not wrong, they're still not exactly insightful, not necessarily helpful or useful. They're not expert at what they do. And this actually makes a lot of sense when you think about how they're built, because If you had a brand new intern come in and nothing about construction and you told them to just, read the internet and see and then come back and do their job, you wouldn't expect them to really be able to do that. And that's how these systems are built. They're not actually expert at construction. And this is really part of the core of the spatial AI engine that we're building here. Because what we're doing is we're taking all of the best and most powerful aspects of spatial computing on the one hand, and then similarly pulling out the best and most powerful aspects of generative AI. We're doing this across many different data types, our 360 images, smartphone videos, mobile photos, even documents and tasks. And then we're actually tuning the system specifically for construction and for construction-related tasks. And that's the power of the spatial AI engine. And so what I'd like to do now is actually take you under the hood of some of the products and features that Neil had talked about earlier today, and just talk a little bit about how spatial AI works to actually make those features a reality. So the first one I'm going to talk about is our automatic location pinning. And so this is a short GIF that you saw before that Neil showed you earlier today. And just to refresh your memory, what you're seeing here is our ability that we're introducing to allow you to actually take your smartphone photos and upload them directly from your phone into the OpenSpace system, where the OpenSpace system will then automatically pin the location of those photos onto points onto the floor plan. Now, if you're familiar with our product, you know that this is actually a function, a feature that we've had for a long time while you're taking a capture. So just to show you a little visualization of this, as you're going around taking a 360 video, we're collecting a whole bunch of information as you're doing that. And so if you whip out your phone and take a field note, take a photo, we can use all of that contextual information to know where that photo was and where you were when you took the photo so that we can pin it to the floor plan in the appropriate place. However, when we're trying to do that on mobile photos that you took when you're not taking a capture, we have much less information. This becomes a much harder problem. And so what we have to do there is actually dive into the images themselves and start looking at semantic information about the content or what's in the images. The way this works with the spatial AI engine is that we actually look at the image, we identify salient features in there, and then find matches between the features that exist in the smartphone image and your most recent 360 capture. If the system finds enough of these features in common, it'll actually project that image to that location in the 360 and then onto the floor plan. And so how this works in practice is the 360 captures become something that we call an image map. And as mobile photos come into the system, we can scan those across the image map and looking for those places where the objects in the image match the objects that we see in the image match. And if there's enough confidence in that, we can actually pin that to the floor plan and suggest that location to our users. This is an example of how we can use spatial computing and that spatial intelligence, tune it specifically for construction tasks in order to power a pretty magical feature. So that is the one feature. The next one and the last feature I want to take you under the hood with is our search feature and something that we call Smart Search. So again, I'll flash this image here, this video from Neil's talk where he showed off this ability to actually start searching for objects that appear in images in 360s. And so it's a pretty classic search interface. The idea is you go in and you type in the keyword for the object you're looking for, and then we'll bring the images that have that object up to the top. But what I'd like to show you now is take you kind of under the hood, as I said, and show you a visualization of what's actually happening behind the scenes as the system is doing this. And so here is a video that I'll show you of what's happening behind the scenes here. And what you can see here is a point cloud representation of every image that was taken on a job site over the course of time. And so importantly, this point cloud is not like the point cloud you get out of a laser scan. So the placement of each of these points has nothing to do with physical space or where that image was taken. We can also do that. We also have that information. But rather here, the relationship between the points and the images has to do with how similar those images are together. So 2 points in this visualization are close together if the objects in the image are very related. So for example, if I look at the top here and I just mouse over a couple of the different points there, you can see that these are all images taken in similar stages of construction. But if I go all the way down here, you can see a very different phase where a bunch of images have been kind of clustered together that are all taken in, after finishes have gone in much later phase of construction. And so we sometimes refer to this visualization as the brain behind the search engine. And we call it the brain for a couple of reasons. One is that, it looks a little brain-like. If you kind of squint, it's got kind of a brainy aspect to it. It looks a little bit like kind of an MRI. But the other reason that we call it a brain is because this is actually a lot like how many researchers think the real brain, the human brain, organizes information. The idea being that in the brain, if you have two concepts that are related to each other semantically or in their meaning or how they're used, then they'll actually show up in similar physical locations in the brain. So you might have one part of the brain where things like apples and bananas, the concepts for those are located, and that might be in a very different place than concepts for things like tables and chairs. And so we can use this in order to show off how the search engine works as well. So if I just go back to this visualization, we type in the keyword drywall, and what happens is that part of the brain where drywall actually exists, that gets activated. And if you go and mouse over that little section, you can see that in that region of the brain, these are all places where you can see drywall. Now, keyword search is kind of the first step here, but because the system has been tuned for construction and because we're building in the semantic information that we're pulling from algorithms that we get from generative AI, we can actually take this to the next level and start handling much more complicated and much more valuable types of queries for the system. So for example, we can type in not just the keyword drywall, but the concept drywall sheets that are stacked on the floor, which is much more powerful, much more relevant, especially when you're trying to understand what rooms and zones are staged and ready for the next phase of construction. And you can see that this actually activates a very different part of the brain, the drywall sheet stacked on the floor part of the brain, where those elements exist. Now, we can take that and then layer on the spatial intelligence that we talked about before. So you can actually see where those actual photos are located. And this allows us to do the next level of power. We can actually now even add spatial information to those queries. So we can get very specific information about where sheets of drywall are in particular zones. You can see how this just makes the system more and more powerful because as we add that spatial intelligence that we're getting from spatial computing and combine that with the semantic intelligence that we're learning from generative AI technologies, we can then take all that, put it together, and then tune it specifically for these construction-related tasks. And then this becomes a very powerful system, this spatial AI system that we're developing that can power not just these features that we're talking about today, but a whole suite of features that we'll be talking about over the coming months and years. And so I want to end there with that and just say thank you very much for taking the time to listen to what I had to say. I had a good time. And I'm looking forward to my next opportunity to share more about spatial AI and the features that it will power in the future. Thanks very much.